Lesson 5.1, Midsegments of triangles. A midsegment of a triangle is a segment connecting the midpoints of the two sides of a triangle. Okay, and that segment is called a midsegment. So let's take a look at what a midsegment looks like. In Theorem 5.1, Triangle Midsegment Theorem, if a segment joins the midpoints of the two sides of a triangle, as it does here in D and E, then the segment is parallel to the third side and half as long. Okay, so if we look here, we can see that D is a midpoint of CA because the two parts are marked congruent. These two here, and CE is in the middle of CB because these two sides are marked congruent. So D is a midpoint of AC and E is a midpoint of BC. When this happens, the line that's created is called our midsegment, and therefore it is going to be parallel to the third side, and it's also going to be half as long. Okay, so one way to look at this well, not that. One way to look at this is to think of it this way, okay? So since not every triangle is going to be called ABC and have midsegments DE, we can write this as the midsegment is equal to half, and we're just going to call this the third side, the side that it's parallel to. So half of the third side. And that's what I'll refer to it in this chapter. So midsegment is equal to half the third side that it's parallel to. Now, you can also think of it this way. If the midsegment is half of this, that means that the third side is twice as long as the midsegment. So it takes two midsegments to equal one third side. So both these ways will prove useful in setting up and solving our equations. So the midsegments equal half of the third side, and it takes two midsegments to equal one third side. So it takes two of these DEs to equal one AB. All right, so let's take a look here at first identifying different parts and deciding which one's our midsegment, which one is our third side. So what are three pair of parallel segments in triangle DEF? So here's our triangle DEF, and we have marked here midpoints R for DE, S for EF, and T for DF. So let's identify the three parallel segments. So let's start off with identifying our midsegments, the parts that are on the inside. So let's take a look at RS. RS is going to be parallel to which side? So this is going to be identified as our third side. So if this is our midsegment, then this would be our third side, the one that's parallel to, which would be DF. And then the other one, let's go around the figure here. So let's go around the middle here. Let's take RT. RT, this segment is going to be parallel to which side? Well, it's going to be parallel to this side over here, which is EF, which means EF is its third side. And then our last one, the other side in here, ST. ST is the other midsegment, and it's going to be parallel to the side DE. So we have three sets of parallel sides. RS parallel to DF. We have RT parallel to EF, and then we have ST parallel to DE. All right. You guys try this next one. In triangle XYZ, A is the midpoint of XY, B is the midpoint of ZY, and C is the midpoint of ZX. What are three pairs of parallel segments? So, first start by drawing this figure, identifying, putting the correct points in the right location, and then identify the three parallel segments. So pause your video and come back and check your answer when you're done. All right, so your picture should look something like this. Draw your triangle. The best way to do is draw your triangle. Put points around the middle, so you locate your midpoints, and then draw a line connecting your dots. So this right here, A is in between x, y, B is supposed to be between y, z, and C is between x, z. So AB is parallel to x, z, AC parallel to y, z, and BC is parallel to x, y. So what is the measure of angle VUO in the figure below? Okay, well, let's take a look at what we know here. If this is the midpoint of this side, because these two are congruent, U would be the midpoint of this side, and V is the midpoint of this side, which means UV is our mid-segment. Now, so it says, what is the measure of the angle VUO? So we're looking at the measure of this angle right here. So what is the measure of this angle? Well, if you look over here, we can determine that these are parallel. That's one thing we know about mid-segments and triangles. So it's parallel to its third side. These two sides are parallel. So one thing you always have to remember when you have parallel lines is that you need to be able to recognize those special angle pairs that will occur. This acts as a transversal, so this angle, 65 degrees, is going to be corresponding angle with this angle right here. And we know in parallel lines, corresponding angles are congruent. So the measure of angle VUO is going to equal 65 degrees. Now, had it asked for the angle in UV, this would be this angle here, and it would have been a same side interior angle with 65, and this would have been 115. So, a lot of different questions they can ask. Anytime you have parallel lines, you can have special angle pairs. So now let's look at this. It says triangle QRS. TU and B are midpoints. What are the lengths of TU, UB, and QR? Okay, so let's start by looking to see what we have. Okay, as we write these down, we're going to write these out in kind of algebraic form. We're given the lengths of either the third side or the mid-segment in these triangles. So it tells us they're midpoints. So let's take a look at the first one. We're looking for TU. Okay? TU is a mid-segment, so it means that TU is going to equal half of its third side. Now, the third side is going to be SR. So if TU we're looking for equal to half of the third side SR, and SR is 40, that means that TU is going to equal 20. So this one's going to be 20. And then let's go to the next one, UB. UB is also a mid-segment, so it goes over here on the left. We put the mid-segment on the left, we got the 1/2 of the third side on the right. So let's say we got UB is equal to 1/2 of its third side. And the third side for UB is going to be the side parallel to it, which will be QS. Now they give us the length of QS, so UB is equal to 1/2 of 50, which means this is going to be UB is equal to 25. So it means this segment is 25. Now the last segment is we're looking at the length of QR. So that means that our mid-segment that's across from QR is going to be TB. So this goes over here. TB is equal to 1/2 of QR. Now when we're looking for the third side, sometimes it's easiest if we just go ahead and move this 1/2 over here, multiply both sides by 2, so we get 2 TBs is equal to 1 QR. So 2 times TB, well, TB is 30, and that's equal to QR. So that means that 2 times 30 is 60, so 60 is equal to QR. So we write up here, this one here is 60 going from here to here. So these are our 3 answers. Let's answer the second part of this. Okay, find the perimeter of triangle TUB. So try and find this perimeter. Well, we wrote everything down. We should have that TU was 20 and that UB was 25. So the perimeter of this would be, let's go down here so we can see what we're looking at. Perimeter of triangle TUB would be to add up all the sides. So 20 plus 25 plus 30. So that's going to give us 45 plus 30 is going to give us 75. So if these are half the length of these, what would be the perimeter of the large one? Would it be double what our small one is? Let's check it out and see. If this is 60, then this is going to be 60 plus 40 is 100, 100 plus 50 is... So as these add up to 150, that is going to be double of 75. So it does. The perimeter is doubled the mid-segment perimeter. All right, let's look at the next one. In the figure, AD is 6, DE is 7.5. What are the lengths of DC, AC, EF, and AB? So pause your video, find the lengths of DC, AC, and EF, and AB. And then answer your last question here. Find the perimeter of quadrilateral ADEF. Once you're finished, unpause your video and check to see how you did. All right, so if we mark everything we know that AD is 6. That was given to us up here, and that DE is 7.5. So if these are congruent, then the DC has to also be 6. So that's our first answer. Second answer, it asks for the length of AC. Well, AC is the entire segment here, so 6 plus 6 is 12. Then we're looking for EF. EF is the mid-segment for our third side of AC. So it's equal to half of AC. So we plug in half of 12 and get 6. And the last one here, we're looking for AB. AB is the entire segment here. If this is the mid-segment, because these are made up of, this is a mid-segment by knowing this is midpoint, this is the midpoint of this side. So therefore, this entire segment would be double 7.5, which is 15. So now we'll find the perimeter of the figure quadrilateral ADEF. That means all these four sides here. So we got 6 and 6 and 7.5 and 7.5, which is going to give us a total of 27. So be able to remember, or be able to identify your mid-segments and your third sides. So a geologist wants to determine distance AB across a sinkhole. How far is this sinkhole here? Choosing a point E outside of the sinkhole, she finds the distance AE, okay, which is over here, and BE, this distance over here. She locates the midpoints of C and D, halfway between this line here and halfway between this line here, and then measures the length of CD because it's outside of the sinkhole. What is the distance across the sinkhole? Well, the sinkhole is like a mid-segment problem. This is a midpoint, this is a midpoint, so therefore this is the mid-segment for this third side. So that means that DC is equal to 1/2 of AB. Now since they give us this right here, to find AB, we're going to get rid of the half, which means we're going to double the DC. So 2 DCs is equal to 1 AB. Or 2 mid-segments is equal to 1/3 side. So 2 times 46 is going to equal AB. And that's going to give us 92 is equal to AB. So the sinkhole AB is equal to 92 feet across. Okay, now let's try the next one. You guys try this one. What is the distance across the river? If it's 92 feet across here, and this is 55 and 55, which is letting us know that this is the mid-segment. So that means that this is going to be, this mid-segment, this distance here is going to be half of the 92, which we're using this, end up using the same numbers as we did our previous problem. So our mid-segment would be half of 92, which is going to be 46. So we take 92 and we're going to take half of it, half the third side, and we'll just call this x right here is equal to our x, our mid-segment, and that's going to give us 46. So 46, we'll call that x, and we'll say that is going to equal 46. So 46 feet across the river. All right, that was using indirect measurement, measuring something without physically measuring it. So now let's use algebra to solve with midsegments of triangles. We're going to have variable expressions. So we need to find either the lengths by finding x and then plugging it back in, or we're going to find the value of the variable. So solve for x and then find the length of yw and qr. So first thing we need to do is we need to figure out which one's our midsegment, which one's our third side. These are all midsegment problems. So qr is our midsegment, which means it's going to be qr is equal to half of our segment yw. Now what I would suggest you do, anytime we're using variable expressions or we're trying to solve for x, I would use the other equation where we take two midsegments, so 2 qr's is equal to 1 yw. And this makes working with the variables much easier. So now we can plug in what we have. qr is 2x minus 3, so it's 2 times 2x minus 3 equals yw, which is going to be x plus 9. Distribute the 2, so that gives us 4x minus 6, and that's equal to x plus 9. Now, bring our x's together, solve for x. 3x minus 6 equals 9. Add our 6. 3x equals 15. And that gives us that, when we divide by 3, that x is equal to 5. So once we find our x, now we've got to go back and plug it in to find the values of yw and qr. So for yw, we're going to plug in 5 for x. It's going to be 5 plus 9, which is going to give us 14. And since this is going to be double this one here, qr should be half of 14, which should be 7. So let's plug it in and find out to check. qr is going to be 2 times 5 minus 3. And so 10 minus 3 is going to be 7. So qr is equal to 7 and yw is equal to 14. All right. You guys work this one. Pause your video, work it out, and come back and check your answer when you're done. All right, so we set this up and we're going to do, once again, two midsegments. So 2 CBs is equal to 1 RT. Plug in our expression, 2 times x plus 19 equals x plus 29. That gives us 2x plus 38 equals x plus 29. Now, as you work this, you're going to notice that you're going to get a negative 9 for your answer. And a lot of you were thinking, oh, I can't get a negative. But you can get a negative variable, you just can't have a negative segment. So when you plug this back in, negative 9 plus 19 gives us a positive 10. And when you plug it back into RT, you get negative 9 plus 29, which gives you a positive 20. You still get positive results, so therefore your answers are good. And once again, this becomes out to be 20, and this is 10, where this is half of this segment here. All right, let's try one more. Try part C. Pause the video, come back and check your answer when you're done. All right, so as we look through here, we see that 2ji is equal 1 TV. Plug our expressions in, 2 times x minus 3 equals x plus 6. That gives us x equals 12. So now we go back and plug it in, we can find the length of ji, which is 12 minus 3 is 9. So if this is 9, that means this one should end up being 18. So we can plug that in there, and TV is going to be 12 plus 6 is 18, that's correct. And then for UT, 12 plus 6 again is going to be 18. So we didn't use this side over here to help solve our problem, we just had to plug it in and find the length of TU at the end. All right, so now let's look at what happens when we are going to prove this midsegment theorem. So to show how you know that DE is the midsegment of triangle ABC. So if we're looking at this, we need to figure out what can help us determine that this would be the midsegment. So, a couple ways you could do it. You could look at the distance from A to B and from D to E and see that this is going to be half of this segment here. Okay? Another way you could do it was to plot and find that this point right here would be the midpoint of this line and find that E would be the midpoint of this line. If these are the midpoints, then this would mean that this is this line here would be the midsegment of this triangle. Now, some of you may have thought, well, what if we just look to see if our lines are parallel? And yes, the lines can be parallel, but the thing is, by they're checking their slopes. But just because they're parallel doesn't mean it's a midsegment. I could draw another line with the same slope as this. So this slope right here would be up 3 and over 1. So I could go from here and go up 3 and over 1. And this line here, so I started here and went from this point here, went up 3 and over 1. I could draw another line here that would be parallel to this line here and not necessarily be the midsegment. So that means that we're going to use the midpoint formula. So we're going to find the midpoint of line CA. So we're going to take our 2 points. So we're looking for the point D, which is going to be our midpoint for our X and our Y. Remember, the midpoint formula is where you're going to take and you're going to add your X's, so X1 plus X2 over 2 and Y1 plus Y2 over 2. Okay, so that gives us our midpoint here. So let's plug these numbers in for X and Y. For point D, we're going to get 4. Now, C is located here at 0, 0. So this becomes easier. We're going to do 4 plus 0 divided by 2 and 6 plus 0 divided by 2. Well, 4 divided by 2 is 2. 6 divided by 2 is 3, so this point here is at 2, 3. Okay? So now, and D is located here at 2 and 3, so we can verify that. So that means that D is the midpoint of this line segment. So now let's check to see what the midpoint of line CB is. So we're going to take for point E, find the coordinates of that to check to see if it matches this right here. If we look over here, this is 1, 2, 3. This should be at 3, 0. So let's check to make sure that this comes out to be the same. So we're going to take our x's, 6 plus 0 divided by 2, and 0 plus 0 divided by 2. Gives us 6 over 2, which is 3, and 0 divided by 2 is 0, so that means our answer is in fact 3, 0. So the coordinates of E are at 3, 0. So that means that this is in fact the midpoint of both sides here. Therefore, this is the midsegment of our triangle. So we can say that if we were going to write this out or needed to match this up, so since D is the midpoint of AC and E is the midpoint of BC, then DE is the midsegment of triangle ABC. All right, and that concludes our lesson on midsegments of triangles.